Welcome to the third video of circle theorems, and in this video we are going to solve questions involving angles. So we are going to try and solve these angles by applying the knowledge that we learned in the first and second video on circle theorems. So question 1 says O is the center of the circle. A, B, and C are points on the circumference of the circle. So if you look at that diagram, angle at A is 29. And if you check very well, AB is the diameter of this circle because it's passing through center O. Remember, we cannot assume that O is the center unless we are told. So if you look at this question right there, we are told O is the center. That means AB is our diameter. So from the circle theorems that we learned, the diameter will make a 90 degrees, okay? Let me just show you that. From this theorem, the diameter makes 90 degrees, okay? It's also called angle in a semicircle. So let's get back to our question. So the angle at C will be 90 degrees. Why? Because angle in a semicircle is 90 degrees. So you have 90 degrees, you have 29. That means you can answer this question by getting angle B. So angle B will simply be 180 subtract 29 plus 90 in brackets, okay? And with that, you'll get 61 degrees as your answer. So the angle at B, this one, is 61, sorry. Okay, where do I get 180 from? Angles inside the triangle add up to 180. If you add all the three angles inside the triangle, like this one, you're supposed to get 180 degrees. So if you take 180, subtract the 29 that's given, also subtract the 90 degrees that we get by using a certain theorem, we get 61 as the remaining angle inside triangle ABC. All right, so that's our answer for that question. Let's look at question part B. A, B, and C are points on the circumference of another circle. Now they're saying O is the center of the circle, okay? So we know that O is the center of this circle. That makes angle lines AO and OB to be the radii, okay? These two are radii of the circle. That means they are equal. Now, there's angle at the center there, 112. So using the theorem that says angle at the circumference is half angle at the center, it means we can get angle at C, okay? Angle at C is simply half of 112. And half of 112 is 56 degrees. Okay, please, if you do not understand this, I would recommend you watch the second video on circle theorems. I'll paste the link in the description. So the size of angle ACB is 56 because it's half of the angle made at the circumference by AB. Let's move on to the next question. Question number 2, A, B, C, D are points on the circumference on a circle. Now, if you look well, guys, A, B, C, D is a quadrilateral and it has a special name. We call it cyclic quadrilateral. Why do we call it cyclic quadrilateral? Because its vertices are all touching the circle, okay? The vertices must all be touching the circle for us to call it cyclic quadrilateral, all right? Now, if you remember very well, the theorem that deals with cyclic quadrilateral states that opposite angles in a cyclic quadrilateral add up to 180. Okay? So if we come here and say, okay, question A says find DAB. So DAB is this angle. That's my angle DAB. So we know that that angle at A is opposite the angle at C. Together they are supplementary angles. So we just take 180. Sorry, that's 180. Subtract 62. Okay, you'll get 118. That angle there is 118 degrees. Okay, because opposite angles of a cyclic quad add up to 180. Now, the second part of the question wants ABC. That means they want the angle at B. So angle at B, this one, it's opposite the angle at D for dog. Okay, so now we just take 180, subtract 95, and then you'll get 85 as your answer. So the angle at B is 85 degrees because it's opposite 95. And of course, that one is 118. Okay, guys, let's move on to the next question. Question 3. Question 3 says O is the center. Okay, remember, and I repeat this, do not assume O is the center unless the question says so. So center O, and there's point ABC on the circumference. Looking at this diagram, AB is our diameter, okay, because it's passing through the center. They want the size of angle BAC. So the angle at A, okay? So this angle right here. We all know that angle in a semicircle is 90 because it's subtended by the diameter. So if that angle there is 90, how do we get BAC? So they have also told us additional information which says angle ABC is 20. So this angle right here is 20 degrees. Let me squeeze my 20 right there. So now you have the right angle up there at C, you have angle 20 at B. So you look at that triangle, let me isolate it. Our triangle looks this way with 90 there and 20 here. And angle A is what we want, okay? Now we know angles sum inside a triangle is 180. So if you take 180, subtract 90, subtract 20, okay, you'll get 70 degrees. So angle at A is 70 degrees, okay? Let's move on to question 4. Question 4, there is a ABCD points on the circumference, and they're asking you to find angle X, okay? Angle X. So in this question, we will use the theorem which talks about angles in the same segment, okay? Angles in the same segment. So if I was to take, let me show you. Look at AD. If AD was my chord, okay, it will be making a segment just below it. This is a segment, minor segment, and everything else above it is the major segment. So look at angle 50 and angle X. They're all in the same segment, okay? They are being subtended by AD, and they're all in the same segment. So in our second video on circle theorems, we said angles in the same segment are equal. So that means angle X is simply 50 degrees. All right, angle X is 50 degrees. Let's move on to the next question. Question number 5. Question number 5 is pretty easy. They're saying O is the center of the circle and they want angle W. Look at W very well. That is angle in a semicircle. Angle in a semicircle is 90 degrees. Okay. Now this part B of this question. They're saying you write down the value of X. Look at that diagram that has been inserted inside the circle. That's actually a cyclic quadrilateral. Now, angles in a cyclic quadrilateral, we know that the opposite ones are supplementary, okay? Supplementary simply means they add up to 180. So X is opposite to 116, okay? That means X plus 116 should be 180, all right? That's according to circle theorems on cyclic quadrilateral. Opposite angles add up to 180 for a cyclic quadrilateral. So if I take my 116 to that side, I remain with x. So we'll have 180. 116 has crossed the equal sign, it becomes negative. So 180 subtract 116, okay? We get 64 degrees. So guys, you can see it's very easy to handle these questions once you understand circle theorems. Okay, please, if you have not watched the second video, I recommend you watch it. And remember, I'll paste the link in the video description below. Let's move to the next question on this paper. Angle at, angle Y. We all know angle 52 and Y are in the same segment. Okay, so 52 and Y is the same. So angle Y is same 52 degrees. Okay, sorry about that. Let me just clear the drawing. O is the center of this circle. This is our new circle. We're saying O is the center, and they want angle Z. Okay, now if you look at this circle and the lines inside it, we are thinking about the theorem which talks about angle at the center and angle at the circumference. Angle subtended at the center is twice the angle subtended at the circumference. Okay, so that means angle Z is actually 88 divided by 2, or half of 88. Okay, so that will make 44 degrees. So angle Z up there is 44 degrees. Okay, let's get another question. Oh, right there, question 6. P, Q, R, and S are 4 points on a circumference of a circle. PR meets QS at A. Okay, so this looks a bit complex, but it's very easy. Okay, you just have to look at it in two ways. Look at PS, you get done with it. Then you look at QR. Okay, so let's see PS. Let's look at PS. If you look at PS, the angles in the same segment becomes 57 and the angle at Q. 57 and the angle at Q are in the same segment. So the angle at Q is also 57. Okay, because you look like this. Let me show you. Sorry, that's not a very good circle. It looks like that. You have your PS. Okay. Now you have PS making 57 there. And PS also making Q there. Okay. So you can see these angles are angles in the same segment. So angle at Q is also 57. And with this information, guys, you can get angle Y, because now you simply isolate this triangle, triangle QAP. That's my triangle QAP. I just want to isolate it that way so that I have 57 there and I have 78 here. And I have Y here. So angles in a triangle add up to 180. That means to get angle Y, I'll just take 180. I subtract 57. I subtract 78, okay? And if you do that, what do you get? 180 minus 57 minus 78, you get 45 degrees. So angle Y is 45 degrees. All right. Let's get another question. Just a minute. Something a bit more complex. Okay. Something a bit more complex to do. Oh, number 12. Huh? Number 12 actually contains a theorem that we haven't done yet. I mean, like in the questions, huh? But of course, we had explained it in the second video on this. So number 12, they want angle ABC, okay? And you've been reminded that DAE is a tangent, okay? DAE is a tangent and they want angle ABC. C. ABC, they want this angle, okay? So we talk about angle in the alternate segment, okay? So this angle B is being made in which segment of the circle? Look at the chord AC. Chord AC makes angle B in this segment of the circle, okay? That's the segment where angle B is being made. And it's being subtended by chord C. Now chord C is making 61 with the tangent, okay? So it means angle at B is still 61, okay? The theorem is angle in the alternate segment. So the angle at B is 61. So if you look at that, which angle will be 63? 63 will be angle C, okay? Because if you check well, 63 at the tangent there is in this segment. And then you look at the alternate segment to this, it will make angle C up there, right? So angle in the alternate segment, angle B will be 61 degrees, okay? Let me get us another question. Something a bit more complex. Okay, question 13. Question 13, they're saying O is the center of the circle. That's a very important statement. O is the center of the circle. AOC is a straight line. BAO is 24 and ADO is 42. And they want the size of angle CAD. Where is CAD? CAD is there. Okay. Yeah, that's our angle CAD. So now, if O is the center of the circle, some things start coming in mind. Any line from the center to touch the circumference of the circle is a radius, okay? So this will be a radius. Oh, sorry, let me write it nicely. This will be a radius. This will be a radius. This will be a radius. That simply means the lengths of those lines are equal, okay? So if you isolate that triangle, AOD, triangle AOD look like this. AOD with this radius and this 42. So the two radii are equal, making this triangle to be an isosceles triangle. Okay, isosceles triangle is a triangle where two sides are equal. So what do you know about isosceles triangle? The base angles should be equal. Okay, so if this is a radius and this is a radius and they are all equal, it means these base angles are also equal. Okay, so the angle at A is actually 42 degrees because of the isosceles triangle. All right, and then they want the size of angle C, that is ACB. Where is ACB? ACB is right here. Okay, that's our ACB. Now, how do we get ACB? Where is ACB? Okay, now look at a line AC. AC is a diameter. How do I know it's a diameter? Because it's passing through the center of the circle. It's coming from A, which is of the circumference, going until C, which is also on the circumference, and it's passing through O, which we have been told is the center. So AC becomes the diameter of this circle. And AC is making angle B somewhere up there like that. So this calls for the theorem which talks about angle in a semicircle. Okay, angle in a semicircle is 90, or it's right angle. So the angle at B is actually 90 degrees. Okay, guys. So now, if you have 90 degrees there, you can isolate that triangle. It looks like this. Just label it. It's A, B, and C. And that up there is 90 degrees. and this one was given to be 24 degrees, okay? So we want this other angle at C, all right? So it will be 180 because angle sum of a triangle, the total of angles inside a triangle is 180. So I'll take 180, subtract 90 degrees, which is at B, and subtract 24, which is at C, okay? So you'll get the angle to be 66 degrees. So angle ACB is 66 degrees, okay? Let's look at part C of this question. Just part C down here. Part C says find angle BCD, okay? BCD. So I'll do it up here just so that we can be able to see the diagram well. They want angle BCD. Where is BCD? BCD is the whole of this. Okay. That is BCD. Now, this is how we do BCD. Look at ABCD. That shape is a cyclic quadrilateral because all the vertices are touching the circumference of the circle. So what do we know about cyclic quadrilaterals? Their opposite angles are supplementary, okay? So angle C inside the cyclic quadrilateral is actually opposite angle A inside the cyclic quadrilateral. So the angle at A and the angle at C should give us 180, okay? That's the theorem of cyclic quadrilateral. What is the angle at A? The angle at A, the whole of it was actually 24, and the missing piece we found to be 42. If you have been recording this down, it was 42. So the total of angle A is actually 24 plus 42. If you add angle C, we're supposed to get 180 degrees. Okay, so this missing part here, it was 42. So now if you add these two, you get 66 plus C equals to 180. Then I throw my 66 to that side, it becomes minus because on this side it was positive. So C remains alone, 180 minus 66. If you subtract these two, you'll get 114. So angle BCD is actually 114. Okay. So that's it, guys. I hope this was helpful, and I'll try and do a fourth video, which I'll just borrow one of the largest questions that can be set on circle theorems from an IGCSE paper, the Cambridge paper I mean, and then we'll solve that question, possibly giving reasons for every solution, okay? But at the end of this video, at this moment, you should be able to handle almost any question on circle theorems. I hope this was helpful. I'll actually appreciate your comments, your likes on the video, and your views. Thank you very much.
Audio Jungle.